My name is Shea Lemar. I am one of your moderators today, and I think we're ready to get started. So we are going to start with Ms. Sandy Dyre, who will be speaking about understanding the data supply chain background. Ms. Dyre has over 29 years of experience in the 911 and public safety industry, proven ability to design, develop, and implement solutions in both an enhanced 911 and next-gen 911 environment. Strong business acumen and with well-developed project management and leadership qualities. Areas of expertise include strategic planning, project management, 911 systems and networks, master street address guide, GIS for 911 and Indy 911 training, and public speaking. In addition, Ms. Dyre also recently helped to write several articles, including one of the most recent issues of the Journal of Emergency Dispatch and Call magazine. Ms. Dyre, please take it away.
Wow, so I didn't realize I should submit a bio that was much shorter. I thought that was for print, not for reading. Let me apologize to everybody about that. Is everyone seeing my PowerPoint? I just want to verify that first.
Yes.
Okay, I am not going to do my video because I've done enough virtual conferences to know that the video and trying to present and speak at the same time is a little bit too much bandwidth. Okay, so welcome to Understanding the Data Supply Chain Breakdown. I'm really glad everybody's joining today. So as Shea shared, I am Sandy Dyre. I'm a public safety expert with DataMark, and I have had a long career in public safety spanning back to 1990. I did have the pleasure to support Arizona 911, starting as a role as a 911 dispatcher all the way to 911 administration, both at a county and a state level. I also enjoy being a co-chair for the National Emergency Number Association. NENA is the standards body for 911. I co-chair their real-time text working group for if there's any public safety folks on this session. That document has been finalized and it will be publicly available in the next couple months. I also co-chaired the GIS data stewardship for NG 911 for the PSAP boundaries specifically. That document is available now. And I co-chair the same GIS data stewardship for NG 911, but focusing on the road centerline layer. That work group is currently developing content. So just wanted to share that out in case you're in the 911 spectrum or you're going in the 911 spectrum and you're needing guidance. NENA has plenty of standards, requirements, and information documents to support you. And I am also a proud committee member of the AJAC 911 committee. I've been a committee member since 2012. Now, while I'm not a GIS person by trade, GIS in 911 has been a constant throughout my career, with Next Generation 911, a GIS-based 911 system, being the most impactful thus far. It is because of the complexity of NG 911 that I wanted to discuss data supply chains today. So today we're actually going to take a quick glimpse of the data supply chain with the goal to help define some components of the chain. I'm hoping in a way that will help you to consider if you have a data supply chain at your agency, and if not, perhaps I can encourage you to institute one. Now, I'm going to use Next Generation 911 as an example business need, but I hope that the descriptions I've included are going to really help bridge your own business needs, and you'll be able to apply them on your own. Data has become one of the greatest assets for government, and depending on the system there to support that asset, it can be the biggest risk if the data we use isn't up to date and reliable. And I know I'm speaking to the choir on this one. The concept of a data supply chain isn't new. Even this article is 5 years old. Surprisingly, though, most don't know what a data supply chain is. Many describe the data supply chain as a life cycle of data, and that's a good description. Although I believe a data supply chain is more than a life cycle, it includes the environment that supports everything about the life cycle. And as this article describes, a data supply system is a system of processes in which something enters the system, undergoes a transformation, and emerges on the other side as something of value to be delivered to people who can use it. Geographic Information Systems, GIS, already understand the concepts of processes that enter a system, undergoes transformation, and emerges on the other side as something of value to be delivered to people who can use it. Not only that, GIS has the components needed for an effective data supply chain. The concepts behind GIS can be easily broken out and applied to define a data supply chain for any government business need. Technology, people, and the data isn't enough to ensure updated and accurate information to support government and the people it serves. Without the proper workflows, processes, and communication to properly receive and disseminate information, the infrastructure put into place just isn't efficient. So why do we need a data supply chain? Well, regardless of what your business need is, whatever you're supporting, whether you're a DOT supporting road infrastructure, meeting requirements for essential funding like ADOT and the Arnold program, Department of Revenue executing legislatively defined tax assessments and collections, or in the example that we'll use today, 911 saving lives, the flow of data determines whether your data supply chain exists or not. So consider the purpose of Next Generation 911. NG911 needs to be able to better define the world around us so that we can locate you and route the 911 call. Next Generation 911 is a GIS-based 911 system, and we're needing your GIS to perform these essential functions. Now, this is a huge lift and requires the resources and involvement of new stakeholders and developing the communication needed to support the proper relationships for the engagement and commitment that is needed for NG911. The data that is needed to support NG911, as well as the capability to remediate, maintain, and provision the data based on the defined standards. And then much like Brian Bond talked about earlier, memorializing those efforts and data needs with our stakeholders through our processes, workflows, and agreements. Brian had a great presentation on agreements today. A key part of our processes and workflows are the technologies needed to support those efforts. Now, preferably a common operating picture will be used to support those needs, either in a real-time or a close to real-time basis. And I think because of all these things, why NG911 needs a data supply chain. So the first aspect of the data supply chain is the stakeholder. And actually, the Next Generation 911 panel had a really great discussion that included a number of stakeholders and how many people have to be reached out and touched in order for their data to be complete. The stakeholders for Next Generation 911 are GIS, addressing authorities, public safety, and then other stakeholders such as your state 911 office, Next Generation 911 system service providers, so your providers on the other side of the spectrum. AZGO is another stakeholder of the data that's collected. And stakeholders generally fall along a continuum between the provider, the aggregator, and the consumer. Now, providers for today's discussion are generally considered the source of records of authority. An example of this is going to be like a single municipality that has both an addressing authority and a GIS division that provide addressing information to a county for the purpose of maybe updating a master address database. Aggregators, on the other hand, are those agencies that consume and integrate data from the providers and incorporate those records of authority into a larger collective data set. Say it's going to be a countywide, a regional, or a state-level data set. Much like Steve Whitney at Pima County, he supports a statewide 911 data set for Arizona DPS. And then consumers can be you as a provider and an aggregator, but then it's also going to be those individual agencies like your planning departments, ADOT, 911, permitting department, whoever you can think of, and I want you to think of who those consumers may be because they're a part of your data supply chain, your coworkers, and then of course the citizens that use the information. Consider who are the stakeholders for your individual business needs and whether they should be included in your supply chain. I know I already said that once, but it's really important. If you're leaving a stakeholder out, then your data supply chain is not as complete as it should be. The second aspect is data, and specifically I want to talk about authoritative data. So for NG911, the NG911 system necessitates change in the way the data is created, communicated, and managed within a data supply chain. Authoritative data that can meet the requirements is necessary for NG911 to work. Not just any road centerline data set can support the related standards and requirements of NG911. nor would you want it to. I mean, think about when you're asking a road centerline layer to locate you when you dial 911 and route you to the right 911 center, would you want just any road centerline data set to be used? Data consumed into the data supply chain should be data from an authoritative source, say your local GIS data provider, who shares an equal desire for data to be highly accurate and timely. In the past, broad area data aggregation projects have taught us that standardization, open lines of communication, and information sharing are going to be key to the success. Now, each industry has its own requirements, standards, and needs, and Lord knows, anybody who's in NG 911 knows that we have a whole list of standards, requirements, and information documents. Defined processes and workflows are going to help to ensure that these requirements are being met, that they consume any temporal aspects of the requirements, and that they assign the roles and responsibilities to the proper department. The best data supply chain has the ability to not only support emergent circumstances, but day-to-day operations. So as in this example, consider this requirement for NG 911, the 3 business day turnaround, which Jeff from DataMark mentioned earlier in his presentation. The data supply chain would need to consider the depth of this type of inquiry may have to reach its resolution. So when I say depth, I mean how far down in my data supply chain does this requirement need to go to reach the right authoritative data source for resolution in a 3 business day turnaround? So let's kind of break up both. There was actually 2 requirements in that example. And with a 3 business day turnaround within NG 911, the time requirement for resolution from when you of a discrepancy report that's generated as part of an active 911 call. The system is built to where if a 911 call fails, a discrepancy report is sent to the 911 authority, and they have 3 business day turnaround to be able to resolve that. What would that process be to support this very temporal requirement? Now think about it. The error is sent from the next generation 911 system service provider to who? What does your data supply chain look like? You're going to send it to the state 911 office, who then sends it to the 911 system administrator, who shares it to the 911 GIS data provider, who then communicates back to the local data provider for clarification if they're unable to resolve it on their own, and then back up the same path within 3 business days. How many of your GIS departments would be able to support that without the right data supply chain? Or is the path shortened, so you can add in or remove different contributors to that, but still allow all the same visibility to all the stakeholders, the state, the 911 authority, the GIS data provider, your local data provider. But say it goes from the 911 system service provider to the 911 authority, the 911 data aggregator, and then to the local data provider, and then back up the path. But these are things that we need 911 systems to consider with their GIS partners. Now, the second part of this requirement from the same document is that we have to consider the quality assurance and quality control that happens prior to provisioning the data that was used for the 911 call. Now, does the same workflow support this requirement? We hope so. And how do you indicate a normal request versus an emergent request? So if you use the same workflow, how do you notify the people in the workflow that this is an emergency, this is a 3-day turnaround versus this is a day-to-day operation? When the data supply chain considers all those demands, whether emergent or day-to-day operations, a more efficient process can be instituted. And for NG 911 folks, that means we're saving lives. Technology, whether it's going to be disparate systems such as individual GIS infrastructure, email notifications, shared environments, or a common operating picture, is an aspect of the data supply chain that can enhance the ability to efficiently support data. The data supply chain of any data, whether an NG 911 system within an NG 911 system implies temporal constraints and therefore necessitates additional collaboration mechanisms and near real-time access to data from authoritative resources. Stakeholders, data, processes, and technology are needed at every level of coordination And not only do the coordination efforts need to be defined at every level, but they should complement each other for the best outcome. So if I'm going to define the coordination levels or efforts at one level, and I'm going to define kind of in a vacuum the coordination efforts at a different level, and those two conflict, how efficient is my data supply chain? So let's consider, and this goes back to the NG91 panel discussion. We had a really great discussion about all their stakeholders and how they aggregate their data and how they disseminate it back out. And I don't know if they realize it, but they're kind of talking about their data supply chain. But let's consider the stakeholders, data processes, and technology you need between your local 911 centers, your addressing authorities, your GIS data providers, to your regional, or say it's a county level 911 authority and GIS data aggregator. Then consider the stakeholders, data processes, and technology between the county level 911 authority and the GIS data provider, and say your next generation 911 system service provider or the state 911 office. And then what about all the other valuable local, state, federal, and tribal stakeholders? And then, of course, optimally to AZGO. Or maybe the data supply chain for NG911 operates on a common operating platform, so on a common operating system that can seamlessly connect to the local, state, federal, and tribal stakeholders who are also connecting to AZGO, and that they're operating their own common operating system, their own data supply chain, and that these two systems can seamlessly connect. That in itself makes for the most efficient use of data at every political subdivision level, especially when AZGO is considered the authoritative data source for so many in the state, and I know that from experience. So considering that GIS is a mission critical and in 911 a life-saving asset, we need data supply chains to mitigate our risk. And folks who have heard me talk before, when it comes to next generation 911, there's no disclaimer. Someone doesn't dial 911 and a disclaimer pops up that says, hey, use the system at your own risk before we place your call. So what we have to do is have the right data supply chain in place to mitigate that risk of people using our GIS data to get emergency services. And that's going to need a common operating system that allows our stakeholders to engage and participate and allows for those communication lines to happen, that connects them to the authoritative data that they need to support these 911 calls, that they've considered their workflows and processes and whether or not those workflows and processes can handle both emergent requests like our 3 business day turnaround or their day-to-day operations, just ensuring that the validations are happening before we even provision for the 911 call. And that all the agreements are in place to solidify and memorialize these relationships. And technology is going to be a really great way to support all that. You can put a common operating picture in place that can support all those things, but the agreements are still going to need to be there because technology can't solve every process. Anyhow, so that's my discussion on data supply chain. I hope I did it in a way that you can apply it locally, that you could see, even from an NG91 discussion, how you could apply this in your business need environment, and I'll see if there's any questions.
Thank you so much, Sandy. Anyone who wants to put their question in a chat or even let me know you have a question via chat, that'd be great. Sandy, Shauna asked if you might be able to provide the URL for more information on NG911 and on Nina into the chat so that she could do a little more investigation on her own. That would be great.
Absolutely. Actually, so Shauna Ray, I have a whole list of, because I get this request fairly often, of all the standards and requirements. And if it's okay, I will email you that list, and it has the links directly to the document. It's a very big list. Let me know if you need help navigating them.
Great. She says, excellent. That'd be wonderful. Any other questions? Great. Thank you again so much, Sandy. That was wonderful. And in keeping on the theme of things related to 911 and safety and people getting to places we need, next we'll be hearing from John. I'm sorry if I slaughter your last name. Is it Ehlen?
Oh, it's Ehlen.
Ehlen. Darn it. We'll be hearing from John Ehlen, who is a geospatial professional with a passion for solving problems. He currently resides in Prescott and works for Yavapai County. His work tasks include data aggregation and validation and schema transformations for the purpose of migrating the county to NG911. In his free time, he likes to experiment with new technologies while creating educational and informational maps and applications. And John has his master's in GIS technology and his bachelor's in parks and recreation management. So thank you, John.
All right, thank you so much. Can you guys see my screen here?
Yes.
Okay, let me figure out how to get the control panel back up so I can turn off the camera. Let's see here.
Oh, John, I can turn off your camera if you would like.
Yeah, perfect, because I can't figure out how to get the control panel back up. All
I
right.
never can either. Okay, I think we're good.
Let's get that off the screen. All right. All right, well, so hello and thank you all for attending my presentation today at AGIC 2020. As was noted, my name is John Ehlen, and today I'll be talking briefly about visualizing attribute errors between related road centerline and address data sets. I will be doing this using a technique called a fishbone analysis. So without further delay, let's go ahead and dive right in. So what is a fishbone analysis? Well, a fishbone analysis, also called a cause and effect diagram, is one method of relating and exploring the contributing factors of a known outcome. This works by first identifying the outcome, then by identifying the major factors that contributed to that outcome, and then by investigating the specific components of each of the major contributing factors. In our case, the known outcome is the physical placement of the geocoded address points along the road segment. The major factors contributing to the physical placement become our original address points, and the supporting components that influence the placement are the common attributes that are shared between both the address points and the road centerline data sets. These attributes are what determine the placement of the fishbones, and they include things like street names, address ranges, incorporated municipalities, and emergency service number zones. So how is this useful to us? Well, in terms of GIS, it is an analysis tool that can assist in visualizing attribute errors between road centerlines and address points. In general, when the shared attributes are correctly populated in both, the line work produced should be relatively short, spaced at somewhat even intervals, and non-intersecting when drawn between the original address location and the geocoded address location. When the connection lines intersect, it is usually indicative of an error. These errors can come in many different forms, but almost always relate to the attributes of either the address point, the road centerline segment, or both. Occasionally, errors relating to the physical placement of either the address or the centerline segment may be the root cause. This analysis creates a visual aid to help you spot attribute errors that can otherwise slip through the cracks. Although it's not as widely known as other federal standards, the fishbone analysis is actually part of the Federal Geographic Data Committee's standards as stated in the United States Thoroughfare, Landmark, and Postal Address Data Standard document. Specifically, it is found in Part 4, Address Data Quality, in Section 4.5.5, Address Number Fishbonesmeasure. This section begins on page 238 of the document, and in this section, it specifies a number of issues to check for, including addresses without a fishbone, intersecting fishbones, fishbones intersecting streets, long fishbone lines, and fishbones that all meet in one location. We will investigate some of these issues later in this presentation. So, what do you need to get started? Well, at the very least, you will need a data set of addresses and road centerlines, as well as an address locator that has been built from your own data. The locator that works best for this task is the US address dual range style, which is ideally suited for the task of identifying a house on a specific side of a street segment. At a minimum, the addresses should include the house number and the full street name. The road centerlines should include the full street name as well as the beginning and ending address ranges for both the left-hand and right-hand sides of each road segment. The road segment should be drawn from start to end in the direction of increasing addresses. While not required, additional attributes like incorporated municipality, emergency service number zone, zip codes, and MSAC communities are strongly encouraged and can help you depending on the end goal. These minimum requirements stated here are based on the minimum requirements to build an address locator using Esri software as specified in Esri documentation. It is possible to replicate this process with other open source software, but that will not be covered in this presentation. So what issues can you identify with the fishbone analysis? Well, as it turns out, there's quite a few. Regarding address points, some of the most common errors are addresses that are numerically out of order in relation to the address grid they are assigned from, address points that have been assigned more than once but should be unique, address points that have been placed on the wrong side of the road segment, and address points that do not align to the real-world placement of the physical structures which they represent. Looking at road centerlines, some of the most common errors are road centerline segments that have been drawn in the wrong direction in relation to their associated address grid, road centerline segments that have address range errors, and road centerline segments with parity issues. Some of the issues that are commonly shared between both datasets are incorrect attributes in the fields for ESN, incorporated municipality, street centerline pre- and post directions, and street names. We will explore some of these examples in a few minutes, but first, let's look at some of the other things we can get out of the Fishbone analysis. The Fishbone connection lines can offer more insight than just a simple visual analysis. At Yavapai County GIS, we keep track of the results for long-term tracking purposes. With each successive run, we try and answer some basic questions about the data. These questions include, what is the longest connection line, and what is the average length of all of the connection lines? Longer lines are usually more indicative of errors than shorter lines, so it's beneficial to focus on the longest ones first. Fishbone lines extending beyond 1,000 feet most likely require investigation. Segment lengths beyond 1,000 feet can indicate many things from incorrect street names to incorrect segment splits at jurisdictional boundaries, but in any case, they should be evaluated. This distance of 1,000 feet is based on the FGDC standards and that's specified in the last document. The next question we ask is, what is the total count of connection line self-intercepts? In this case, the self-intersects do not represent a single line feature intersecting itself, but rather a single line feature overlapping another line feature within the same dataset. These intersects generally point to errors, and this number should decrease over time, especially in the beginning. Keeping in mind, one backward street segment could cause more than 10 plus connection line intersections, so fixing these areas first can lead to a very quick reduction in the number of intersects. We also like to look at the total count of connection lines intersecting road segments. Areas where connection lines intersect road centerline segments almost always attributed to the road centerline segment parity errors. These errors are easily identified by the intersecting pattern they produce, which we'll explore in an example. The final question we ask is, what are the total counts and percentages of matched, unmatched, and tied records from the geocoding process? The matched records should increase over time, while the unmatched and tied records should decrease over time. These geocoding results are also useful as a rough estimate of your data's accuracy. The higher the accuracy of your attributes, the higher the match percentage during the geocoding process will be. Next up, let's look at an overview of the process. So the first step in creating the lines between the original location and the geocode locations is creating a locator. To do this, you must determine the purpose and scope of your work. Are you a small city or a large county? Do all your road segments have names and address ranges? Do you need your center lines grouped by a certain attribute, and does that attribute even exist in your current data? In Yavapai County, I've chosen to group the center lines by the emergency service number, and I have replaced the incorporated municipality with the respective ESN value for each centerline segment during the geocoding process. This was done because each centerline segment is split at ESN boundaries, and the corresponding address points should have the same ESN value as their associated centerline segment. The geocoding process involves 4 individual U.S. dual-range address locators with decreasing levels of specificity, which are then combined into one composite address locator. The second step is geocoding your address. There's no magic here, just run the address data through the address locator you built in the previous step. This will generate the geocoded addresses, which are used to create the Fishbone analysis. These geocoded addresses will be related back to the original address based on the matching address from the geocoding process. Now that you have sets of 2 related points, the original address location and the geocoded address locations, you can use these point pair groupings as the beginning and ending vertices to build connection lines. These lines are easily generated with a small amount of Python code, which will be briefly explored in the next slide. Additionally, a sample script and some sample data will be available for download at the end of this presentation. After you have built the connection lines, intersections of these lines can be quickly identified through Python or through the ArcMap or ArcGIS Pro Intersect tool. All you have to do is run the Intersect tool with only one input dataset, in this case, the connection lines. These intersections can also be identified with other third-party projects like QGIS. Okay, now that you have identified the Fishbone intersections, you can investigate your data and look into why these intersections took place. Was it the address range of the road segment? Was the address a duplicate of another address across the street? Or did the center line the address is geocoded to get named incorrectly? By looking at the attributes, these questions will be answered. Now let's take a look at a short video showing how quickly these lines will be created. So in this 30-second clip that's being played in real time, you're seeing how simple it is to create these lines and how fast the process is. The first thing I did was simply turn on the original addresses in the table of contents, and then I did the same thing for the geocoded addresses. I switched to the Python window, pasted in some Python code, and ran it. Within about a second, connection lines are created between 1,688 points. The code displayed in the bottom half of the screen is the exact code I copied into the Python window, except without the code comments. Looking at the code, I initiated an empty list to hold the connection line geometries. Then I use an ArcPy search cursor to iterate through each geocode address point and retrieve the XY locations of both the original address point and the geocoded address point. The original XY location exists as an attribute within the geocode address points because it was carried over during the geocoding process. After the information has been retrieved with the search cursor, a polyline is created and that a geometry and its associated address are added to the list. The final step is inserting those features into a pre-formatted template feature class using an ArcPy insert cursor. Although this process uses a pre-made feature class, it could be easily altered to create a new feature class on each successive run instead of inserting features into an existing feature class. So now let's take a look at some examples. Here in this example, the beginning and end points of the center line have been marked with green and red circles respectively. In the image on the left, you can see that the road segment starts on the right side of the image and it ends on the left side of the image, indicated by the green starting point and red ending point. It can be hard to see, but the road segment's address range increases from the right side of the image to the left side of the image. However, looking at the addresses on both sides of the segment, the addresses are increasing from the left side of the image to the right side. This discrepancy caused the addresses to geocode to the opposite end of the road segment from where their true location is. Looking at the other image, the road segment has been reversed and the parity of its address ranges has been flipped. Now, the road centerline segment address ranges follow the direction of increasing addresses from left to right, and each address falls along the line in an orderly manner. In this example, the major issue is that the address 7120 East Esteem Way exists in two different places, to the north and south of East Esteem Way. This issue was resolved by having the addressing department review the issue and assign a new address to the point on the southern side of East Esteem Way. Correcting the duplicate address resolved the issue and resulted in non-intersecting lines. While this issue itself was cause enough for investigation, if you look closely, you can actually spot a second error indicated by the fishbone lines. Can you see it? The address on the bottom of the picture geocoded across the street segment to the wrong side of the road. In this case, the second issue was a direct result of the first. Beyond looking solely for places where the fishbone lines self-intersect, it can be beneficial to look for places where the fishbone lines intersect the road network. This issue was also present in the last slide, although it was much harder to see with so many crossing lines. The red circles indicate areas where the connection lines intersected the road segment. This was a direct result of the parity error we mentioned earlier, and the parity error is caused by the backwards centerline segment itself. In the previous example, we were lucky that no structure existed on the parcel and that we could assign a new address with somewhat little effort. However, that will not always be the case. In this slide, we are looking at a repair gone wrong. In the image on the left, the addresses were improperly assigned and did not follow our address grid. They were placed backwards in relation to the address grid's direction of increasing addresses. This resulted in the addresses geocoding to the opposite ends of the centerline segment, which resulted in intersecting fishbone lines. In this instance, a partial repair was done. On the right-hand side, we have a partial repair which resulted in a second issue. The first issue is in the northwest corner of the image, where we have an address that no longer geocodes to any centerline segment. This is a result of a new address being assigned to the address point and the address range of the centerline not being adjusted to compensate for the new address. The address number is 7050, however, note street centerline segment of East Stardust Lane has an address range where 7050 would fit, because the centerline segment's left address range still begins at 7120. Second issue is the intersecting lines in the bottom half of the image. Because the resident lives on this parcel, we legally cannot change the address without the resident's permission. If the resident does not agree to change their address, this issue will persist for the life of the resident or until the ownership changes hands. Similar to the previous example, we are seeing another error caused by centerline segments having an improper address range assigned to them. In the left image, we can see that the address of 7730 East Acre Way is geocoding far to the east and crossing the street segment North Antelope Meadows Drive. This is because the street centerline segment that East Acre Way is addressed off of has a left address range of 7500 to 7700. The address 7730 does not fit into this range. During the geocoding process, the neighboring street segment was found with the same name and same ESN value and an address range of 7702 to 8000. The address range of 7730 did fit into this address range, and so it geocoded successfully to that location. In the image on the right, the address ranges have been adjusted to reflect the actual addressing, and now the address falls on the correct centerline segment. Here, we have a street centerline segment that was mistakenly given a name of its neighboring segment, causing the addresses to fall in the wrong location. Let's take a look at the image on the left first. The addresses on Kofa Road are geocoding far east of the actual road segment, and the addresses on the north are geocoding far east off of the screen. This is because Kofa Road has been extended to the northeast around the bend, and a segment that should have been called Highview Road is called Kofa Road. The segment of East Kofa Road highlighted in blue is the only street segment that should have the name East Kofa Road. Well, how do I know this? By looking at the legal documents, of course. In this image, you can see that the road corridor highlighted in red. The legal description shows the roads correctly and the addresses are in the proper place. However, the segment was misnamed in the GIS and caused the geocoding fallout. In the final example, the image on the left, the address point was placed far away from the actual structure, which caused these lines to intersect. By simply adjusting the address point's location to the location of the structure, the overlapping lines were repaired. Although this is one issue that can be detected, the usefulness of this specific error is entirely dependent on whether you follow site structure-based addressing or access point-based addressing. Mixing the two will often result in overlapping lines. One of the things I wanted to point out in regards to working with this Fishbone data is how to filter the data to a more manageable workload. When I run the Fishbone analysis in Yavapai County, there are close to 150,000 individual line features created. Who has time to look at 150,000 individual lines? I certainly don't, and I imagine you don't either. One way of making this data set more useful and easier to work with is by removing the non-intersecting lines from the data set. A word of caution though, just because the lines do not intersect does not mean there is not an error. It just means if there is an error, it is less predominant than the errors that cause the lines to cross. What you are seeing in the screenshot above is the difference between the full data set of connection lines, geocoded addresses, and original addresses versus the data set composed of only connection lines that intersect and the original and geocoded address points associated with each intersecting line. You can see that by removing the majority of lines and points that do not intersect, the data is significantly reduced and errors that were previously hard to see become immediately present. When I filter the data set in Yavapai County, I end up with 40,000 connection lines instead of 150,000. Now, 40,000 may still sound like a lot, and it is, but keep in mind that one backward street segment may create 10 to 20 or even more of these intersecting lines. In the looped video above, the full data set before being pared down had 12,506 items in this area shown on the screen, including addresses and connection lines. When removing the non-important data and looking at the intersecting data, 1,383 items remained on the screen in this area. That is a reduction of about 89% in terms of visual clutter. When we look at the big picture and look at the totals county-wide, we reduced the number of items needing investigation from 456,000 to 82,000, or about an 82% decrease. And that wraps up my presentation. There is sample data and a sample script for you guys to test out with if you follow the link under the download link. And there is also a web map here that you guys can look at online to kind of visualize what the Fishbone looks like and pan around with.
Wonderful. Thank you so much, John. Would you do me a huge favor? Mela had put in a question specifically about the Python scripts. Could you, I can't copy and paste from a screenshot, could you in the chat paste your download link and paste your Explore Online link and perhaps your email? So
Absolutely.
Great. So we are going to pass it to our final presenter. Thank you again, John, and he'll put those things in the chat so everyone can look at them. Our final presenter is Casey Green. Casey is currently a GIS analyst for the Arizona State Land Department, ASLD. He serves as the data curator for AZGeo. Before joining ASLD, Casey worked as a GIS technician at the Arizona Department of Water Resources. So I know I realized it said that Shea and Jenna would be giving this topic, but as the AZGeo data curator, Casey will be giving this presentation. Thank you, Casey.
Hello. I am so happy to give this presentation because I think the AZGO Data Hub is awesome. And I am looking forward to what you, the users, will do to share and collaborate. So with that said, let's go to our next slide.
Casey, would it be possible to get a little closer to your microphone?
Oh, yeah. One moment. Is that better?
Thank you.
Okay. So the new AZGO Data Hub was modernized in 2019, 2020. The old AZGO was great for data sharing and retrieving data, but AGIC and AZLand felt like it was time to modernize the setup, and with that we launched the new version July 1st, 2020. It's built on the on Esri's hub platform, which allows us to organize people, data, and tools in a seamless manner. Also, it allows us for more community engagement, and it's relatively easy to configure. We can definitely truly leverage existing data with current GIS technology. With that being said, your new AZGeo account will provide you access to data, a slew of online GIS applications. You can even add in custom applications and the shared development, a shared development site also. And in addition to that, the Data Hub is free to access to anyone with no login required. And in addition to that, our team will give you ability to create logins for advanced development opportunities. Next slide. So here's a how to use AZGO logo that we put together, a graphic that we put together. Once again, you can visit the Open Data site without logging in and search a slew of data, GIS data, even documents and other files that people have uploaded to AZGO. As you can see on the side, a public user can view, search, download open data. AZGO user, which is the most popular feature, can participate in groups, view and download group data, access group applications. You can, with the account, you have an ArcGIS online account, and you'll be able to access AGOL applications, which is which will increase productivity if you want to do functions and GIS processes online. In addition to that, each AZGO user will receive 200 credits on ArcGIS Online, which is, I think a really good deal just for signing up as a user. The other two user levels, the AZGO data contributors, they offer all the same thing AZGO would, user would do, but you will also be able to upload and share data through AZGO and create hosted feature services. And the last user option is the AZGO group admin, where you'll actually administer the group that you're associated with and the members. Next slide. Our Open Data Hub is where you can find all this, where you can, download the full data sets of information, spreadsheets. You can even download KML, shape files, and it's really cool because on here you really can't see it, but once you log in, not only will it show you the data set that you were searching for, but it has some associate data sets that you can look at and apply to your GIS project. And also you can copy those APIs, those feature services into your project. I think the great thing about this, because you'll be receiving data for those services that's constantly being updated from the people who uploaded them and from the groups and organizations that uploaded them. It's real-time data. And I think that's something that all GIS professionals want. You want the freshest data, you want it now, you want metadata on it. And AZGO allows us to really get that data in the time that we need it. No more will you have to call or call specific organizations to get data. You can come to AZGO if they so choose and download it, or just copy the feature services into your project. The group and partnerships in AZGO, we have already a number of groups, and I like to highlight one of them. It's the AJ Natural Resources Hydrography Work Group. Right now, they're working on an age-old problem. The hydrography in Arizona really needs to be updated, and they're using the group platform in order to do that. There's a number of agencies from ADWR to AZ Land. All of us are working together to create a new NHD set, which is what AZGO intended the partnerships to look like and more. In addition, the partnerships also include the Arizona Geodata Supply Chain, the COVID Emergency Response. These are our partnerships and separate collaborations that we created on AZGO. We also have back-end groups and that are partnership. The 911 Public Safety Group is one of them, where they're providing they're providing collaboration with each other to perfect the 911 public safety GIS services that people are taking advantage of and communities are taking advantage of each and every day. With that being said, you would need to have an AZGO account to really use those features. That's aside from the free services that we offer in AZGO. We also have the apps. I'm very excited about this part. All these apps are available for AZGO users that sign up for AZGO account. This allows you to do your data collection, take that data, serve it up, and and get it out to the public. It's robust. It allows you to upload as much data as possible. We really have a lot of space for users to take advantage of. Survey 123, dashboards, Experience Builder. Through Experience Builder, we're seeing users collaborate even more, creating experiences for communities to share data and to work with each other and present data that they would have to go through a bevy of channels to get out to the public. And so that's a real exciting aspect of AZGO. And I encourage each and every one of you, if you don't have an account, go ahead and sign up for an account so you can start using these tools and streamline your process of getting your data out to the public. We are going to dive in deep. Shea and Jenna are going to dive in deeper to cover some of these through our technical session on Thursday, where you're going to be able to take advantage of learning how to do data searches, how to create user accounts. We're going to go over how to share data in AZGO and work with the back-end processes, and even how we're creating partnerships and do more with AZGO. And once again, I think this platform is what we call a game changer, because no more will you. We are looking to the day where no more you will have to call different agencies to get all your data. We would like all that to be in AZGO, to be authoritative. Our team is vetting the data. We're going over the metadata so you can ingest that data and use it in your everyday work. And if you have any questions, now's the time.
Thank you, Casey. While people are possibly typing questions in for Casey, I was just going to finish up with a quick showing of what we were going to be showing later this week, as Casey mentioned. So, as Casey went over, there's the Azgo Data Hub, and one of the reasons, it's a rebuild, but one of the reasons, well, a couple of reasons we're super excited about it is it's rebuilt on Hub. So we're already working with a lot of the different cities, counties, state agencies throughout Arizona in partnerships, and so that we can share data, both public and private. So another exciting thing is you don't have to have any user login to use the open data. So if you go to the data, you can see, as Casey mentioned, all sorts of categories. You can search for the open data, and anything that's open to everyone to access, now you can get it through the basic search, whereas before you had to log in even to get free data. And a lot of that is due to you guys at your different cities, counties, and state groups working with your administrators to help them to understand that sharing data can be a good thing for the state of Arizona. Also, as Casey mentioned, anyone can get free access to the open data, but if you go to the main page and create, which is just azgo.az.gov, so if you go to the main page, there is a link to create a user account, and that account has the higher level access that Casey showed you earlier. So that's really valuable. If you're planning on coming to our presentation later in the week, you should try and create an account before you come so that we can show you the back end as well, and you'll be able to get in the back end and play around during the technical session. The groups page, again, just lists all of the public groups that we work with, people that put their data out there. Some of them share it only with each other if it's confidential data. Most of them share with the public as much as they can. So it's a way to collaborate, integrate workflows between cities, counties, different state agencies. It's saving people a lot of time. And then we have metadata information. We're working on a lot of partnerships, so we'll discuss what partnerships mean, how you can take it to the next level. and how you would develop those. And as I mentioned, we'll go over the back end as well, the ability to see groups, the ability to add your own data to ArcGIS Online, and the ability to utilize some of the applications that come with ArcGIS Online using the 200 credits that Casey mentioned. So I'm going to stop sharing. I know Jenna answered at least one question in the chat. And then Brian Bond, Casey, can you remind people that the official organization account is used for posting data? Do you want to speak to that really quickly, Casey?
Yes, and that is correct. That in order to post to a group, you do need to have an official organizational account for organizational groups. So if you're with a organization, I say you're with Pima County or a county group, you will have to have official organizational account in order to post data to that group.
Thank you. And the point of that is so that when people, as Steve mentioned in the presentation this morning, AZGO is meant to be an authoritative data source. So I know that I've gone to certain data sources and just had to search through, if I want the Arizona Trail, I have to search through Shea's 22 Arizona Trail segments from when she took her dog hiking. AZGO is more authoritative by the people who maintain the data, and in addition, by having the group that put the data out there having the account, it ensures consistency over the years. So I don't see any other questions in the chat box. We'll leave this meeting open for a couple minutes in case anyone has any questions for any of the presenters. And otherwise, we look very much forward to seeing you guys tomorrow at 9 for the recap, and then the second keynote address, and then our amazing sponsors and presentations tomorrow. Thank you all very much for coming, and thank you to our presenters for presenting.